All right, guys, we're back on the grind again. Welcome to another episode of CUDA Education. Make sure to subscribe to me on YouTube. Visit my website, cudaeducation.com. I'm your host, Nicholas Main. And basically, I wrote an example of transferring data from the GPU or the graphics card back to the CPU, which is your Intel, the computer, the chip that runs the rest of your computer, right? If you have any questions, comment below. Hit me up on Twitter at CUDA Education or send me an email, cudaeducation@gmail.com. You see the disclaimer, all that good stuff. Now, I'm running CUDA Toolkit 9.0, Windows environment, Visual Studio 2017, nVidia GeForce 1050 Ti graphics card. I basically took the default code from the CUDA Toolkit 9.0 system and cleaned it up for our purposes. So the includes should already be there if you install Toolkit 9.0. Yeah, so basically I'm just gonna run the program. It takes let me just run it. Yeah. So it basically just it launches a kernel and uses the built-in variables that NVIDIA creates when it launches a kernel to um, to build an array that is transferred back to the host and then printed, right? So pretty simple stuff. So I create a CUDA education device. It's just the initial device. Of course, it's 0. And then I use the command CUDA set device, CUDA education. It's the only and the first device on my machine, so it's just the first device 0. So we're going to use that for the execution of CUDA. Now declare the number of threads to use. I have a GeForce 1050 Ti, so the maximum number I could use for one block, for one CUDA block, is 1024. So for your graphics card, it could be more or it could be less, depending on the compute capability of your card and when in the future you're seeing this video. I'm sure, several years in the future, the amount of threads per block might be a lot more than 1024. Or if you have some enterprise level card or what have you, it's more. But just to be safe and to accommodate everyone, I did 256, right? 256 threads per block, right? I didn't do any special processing to create more blocks if you ask for more threads or anything. I'm trying to keep it simple and straightforward for everyone, so I just do 256. So I initialize a variable on the device side that will send data back to the host. We will print this data to the command prompt. So, just a straight initialization of a variable. Declare how much memory we anticipate device variable to use. So we figure, okay, the number of threads times the amount of space that an integer takes for in memory. We multiply the two and we get memory space. So that's sort of, the value of how much space we need. So set up memory allocation for device variable to send back to host. So cudaMalloc, that's a special CUDA command to basically manage the memory of the device variable. So we allocate this on the device, on the graphics card, right? So now we create launch kernel variables for launch, right? So for the thread blocks, it's the number of threads, so it's going to be the 256, and then we're just doing one grid. Normally, of course, this grid number is a calculated value because, of course, if you use the number of threads per block, or your data is way more than how much ever data points or how much ever threads can hold in a block, you have to create more blocks, right? So not to confuse you or anything, I just do one block, and that's why you have this 1024 limit, right? So launch you launch the kernel with these parameters. Now I also pass as an argument this guy because I'm gonna use it to transfer the data back to the host. So this is launching the kernel, right? And I tell the CPU with this command, CUDA device synchronize, to pause until the kernel is finished doing its stuff before proceeding, right? Because everything that I do after this is basically dependent on the conclusion of the kernel, right? So let's go to the kernel. Basically what the kernel does, you have the global keyword, CUDA Education Sync Threads kernel. That's just the name I use for now. And we have our argument that we passed in, right? And all it does is it takes the built-in number or index number from the GPU, from nVidia, and we use it to basically record and declare values in the device holder variable. So 0 is 0, 1 is 1, 255 is 255, right? Pretty simple stuff, nothing crazy. And that's it. So we do the device synchronize, make sure it's finished doing its thing before it proceeds. And then we create a host variable to receive data from device. So this basically, what you're doing, create a host variable, right? So we just create the variable for the host, and then we allocate memory for it. It's gonna be the same amount as for the device because it's basically supposed to match what's coming in from the device, right? And then we do the copy data from device to host. So we do CUDA mem copy, right? And host variable receive data from device variable to send it. So this is the destination. This is the source. This is the amount of memory we're transferring. And this is the command. CUDA mem copy device to host. You have to be very careful of what direction you're going because there's also CUDA mem copy host to device, which means you're moving stuff from the host and over to the device. But in our case, we're moving stuff from the device, which is up here. We're moving stuff from the device and we're moving it to the host, right? Pretty simple stuff. Once we get the variable, all we do is we run a typical for loop and we print out the values. And basically it's, you could run it again. Basically it's all these guys, right? Nothing too special, right? But that's how you basically transfer data from the GPU to the CPU. All right, guys, please remember to visit my site, subscribe to my YouTube channel, hit me up on Twitter. You could email me if you want to also. And please donate, tell your friends about CUDA Education. We're trying to really really learn this stuff and just get a good grip on the power of CUDA. It's in many ways the future. Artificial intelligence, machine learning, autonomous driving, all that stuff runs on CUDA. So I figure if you know CUDA, you would be good to go. All right, have a great day, guys.